Hi everyone, this is Ms. Helms, and by the end of this video, you should be able to apply the side-side-side criterion for two triangles to be similar. Taking a look at this first video, we are asked which of the following three triangles are similar. So there are two typos. I apologize for these. QS should be 10 and XZ should be 12. So please go ahead and make those changes in your notes. I apologize again. Starting off, we can figure out if two triangles are similar based on if their sides are proportional. What we just learned about is if three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So really what we need to do is set up our ratios and see are the sides proportional to each other. So starting with our first two triangles, QRS and WVT, we need to match up our corresponding parts. So I'm going to start with the smallest side length, which is RS, which has a side length of 4. And 4 would correspond with the smallest side length in the second triangle, WVT, so 6. So 4 over 6, is that equal to, we're going to take a look at the next largest side length, 8 would correspond with 12 between these two triangles. And last but not least, we've got our longest side, 10, or QS, would correspond with WT, which is 15. So our question is, do these all reduce to the same ratio, or are all of these equal to each other? Taking a look, 4 over 6 reduces to 2/3. 8 over 12 reduces to 2/3. And 10 over 15 also reduces to 2/3. Therefore, since they all reduce to the same value, they are proportional. So we can state that triangle QRS is similar to triangle TVW by side, side, side. Okay, well, we've checked the first two, but now there are others to check. So, taking a look at our next example, we know, let's go ahead and compare triangle TVW with triangle XYZ. In a similar fashion, we want to start with the smallest side. So 6 is the smallest side in triangle TVW, and 6 is also the smallest side in triangle XYZ. So 6 over 6, is that equal to, let's go to the next largest side length, which would be 12 and 10. 12 over 10, and is that equal to the longest side length, which is 15 and 12? So 15 over 12. Notice all of the values in the numerator correspond with triangle TVW, and all of the values in the denominator correspond with triangle XYZ. So we're going to go ahead and simplify each of these. 6 over 6 reduces to 1 over 1. 12 over 10 reduces to 6 over 5, which is not equal to 1 over 1. And 15 over 12 reduces to 5 over 4, which is not equal to 6 over 5 or 1 over 1. So since the sides are not proportional, these triangles are not similar. Last but not least, we have our first triangle and our last triangle. So taking a look at our smallest side lengths, we have 4 over 6. Is that equal to 8 over 10? And is that equal to our longest side length of 10 over 12? When we go ahead and simplify each of these, 4 over 6 reduces to 2 over 3. 8 over 10 reduces to 4 over 5. These are not equal, so we know automatically that these triangles are not similar. And let's just take a look at the final one. 10 over 12 reduces to 5 over 6. So since their sides are not proportional, these triangles are not similar either. So not similar. So this is a process that we would use to apply the side-side-side criterion to determine whether or not triangles are similar. Nice work!